Imagine traveling to Mars in just a few weeks, reaching Saturn in months, or even visiting another star within a human lifetime. It sounds like science fiction, but one incredible technology could make it possible: antimatter propulsion. Antimatter is the opposite of normal matter. Every particle we know has an antimatter twin with the same mass but an opposite electric charge. For example, the electron has the positron and the proton has the antiproton. When matter and antimatter meet, something extraordinary happens. Instead of simply burning like fuel, they completely annihilate each other, converting nearly 100% of their mass into pure energy. This follows Einstein's famous equation, E equals mc squared. No other known fuel releases as much energy from such a tiny amount of mass. To put this into perspective, just 1 gram of antimatter reacting with 1 gram of matter would release energy comparable to a nuclear explosion. That's why scientists consider antimatter the most powerful fuel ever discovered. Today's rockets use chemical fuels, which are reliable but relatively inefficient. They carry massive fuel tanks and still take 6 to 9 months to reach Mars. Antimatter propulsion could dramatically reduce travel time because it produces millions of times more energy than conventional rocket fuel. So how would an antimatter engine work? Scientists propose storing tiny amounts of antimatter inside magnetic traps. Since antimatter cannot touch normal matter, magnetic fields keep it suspended in a vacuum. When thrust is needed, a tiny amount of antimatter is released to collide with normal matter. The resulting annihilation creates extremely energetic particles, which are directed out of the spacecraft using magnetic fields, producing powerful thrust. There are several proposed designs, including antimatter thermal rockets, antimatter-powered ion engines, and even advanced beam propulsion systems. Each aims to use antimatter's enormous energy in different ways to power spacecraft farther and faster than ever before. If antimatter is so powerful, why aren't we using it today? The answer is simple. It is incredibly difficult and expensive to produce. Facilities like CERN create only microscopic amounts using particle accelerators. In fact, all the antimatter humanity has ever produced amounts to far less than a gram. Producing just 1 gram would currently cost trillions of dollars. Storage is another major challenge. Antimatter must never come into contact with ordinary matter. Even the smallest containment failure would cause it to annihilate instantly, releasing tremendous energy. Building a storage system that is both safe and reliable remains one of the biggest engineering challenges in modern science. Despite these obstacles, researchers continue studying antimatter propulsion. Space agencies, including NASA, have explored concepts for future deep space missions. Advances in particle physics, magnetic confinement, and energy technology may one day make antimatter propulsion practical. Although we are still decades away from building an antimatter-powered spacecraft, the science behind it is real. If humanity can overcome the challenges of production and storage, antimatter propulsion could revolutionize space exploration, making journeys across our solar system, and perhaps even to nearby stars, a reality. The future of space travel may not depend on bigger rockets, but on mastering the most powerful fuel in the universe: antimatter.